Mars has always been a source of fascination for humanity, with its striking red hue and its proximity to Earth. For decades, scientists and researchers have been exploring the possibility of sending humans to Mars to establish a permanent base, and this dream is slowly becoming a reality. With recent advancements in technology and a renewed interest in space exploration, the idea of building a Mars base is no longer a far-fetched concept, but rather a realistic goal that we could achieve in the near future. A Mars base would not only provide a platform for scientific research, but could also serve as a stepping stone for further space exploration and potentially even human colonization of other planets. However, building a Mars base presents numerous challenges and requires innovative solutions to overcome the harsh conditions of the Martian environment. In this video, we will explore the many aspects of a Mars base, from its location to the potential for scientific research and the challenges of sustaining human life in such an extreme environment. So sit back, relax, and let's explore the possibilities of a Mars base together.
Selecting the right location for a Mars base is critical for its success. The first factor to consider is the geology of the site. The base needs to be built on a stable surface that is unlikely to shift or collapse over time. Mars is known for its rugged terrain, so finding a level area with good stability can be challenging.
Another important factor is accessibility to resources. Water is a critical resource for sustaining human life, and Mars is known to have subsurface water ice in many regions. Therefore, a Mars base would need to be located near a source of water to ensure a reliable supply for the astronauts.
Proximity to potential scientific research sites is also a key consideration. Mars is home to many fascinating geological features, such as canyons, volcanoes, and ancient riverbeds. A base located near these sites would provide scientists with easier access to conduct research.
The location of a Mars base can also impact its overall success. For example, a base located too close to the Martian poles may experience long periods of darkness during winter months, which could impact energy production and the mental health of the astronauts. Similarly, a base located too far from potential resources may require long supply chains that are difficult and expensive to maintain.
When designing a Mars base, there are several key considerations to take into account. Firstly, the layout of the base must be carefully planned to maximize the use of available space and ensure that all necessary facilities and equipment can be accommodated.
The construction materials for a Mars base must also be carefully selected to ensure that they can withstand the extreme environmental conditions on the planet. Materials that are resistant to radiation, temperature fluctuations, and dust storms would be ideal.
Living quarters must also be carefully designed to provide a comfortable and safe living environment for astronauts. The base would need to be pressurized and temperature controlled to provide a habitable environment, while also minimizing energy consumption.
Another important consideration when designing a Mars base is the use of natural resources. The base would need to be designed to make use of local resources, such as water and minerals, to reduce the need for supplies to be shipped from Earth.
In terms of facilities, the base would need to include a laboratory for scientific research, a greenhouse for growing food, and a workshop for maintenance and repairs. There would also need to be a communications center to enable astronauts to stay in contact with Earth.
One innovative approach to designing a Mars base is to use 3D printing technology. This would allow for the creation of structures and equipment using local materials, reducing the need for expensive and time-consuming supply missions from Earth.
Creating a self-sustaining system on Mars is a daunting task, as the planet's harsh environment makes it difficult for humans to survive without a constant supply of resources. One of the most critical components of a Mars base's infrastructure is the water filtration system. On Mars, water is scarce, and it is crucial to have a reliable system for filtering and recycling wastewater. A Mars base would require a complex water filtration system that could convert dirty water into clean drinking water, as well as reclaim water from other sources such as urine and sweat.
Another essential component of a Mars base's infrastructure is air filtration. On Mars, the atmosphere is thin and lacks the oxygen that humans need to survive. A reliable system for generating oxygen is, therefore, a critical requirement for a Mars base. A Mars base would also require an air filtration system to remove toxins from the air and maintain a safe and healthy living environment for astronauts.
Waste disposal is another critical component of a Mars base's infrastructure. On Earth, we are accustomed to flushing our waste away with ease. However, on Mars, waste management is a much more complex issue. A Mars base would require a system for collecting and disposing of human waste, food waste, and other types of garbage. Ideally, this system would be designed to recycle and reuse as much waste as possible to reduce the amount of waste generated by the base.
Finally, a Mars base would require a reliable and sustainable energy source. Solar power is the most likely candidate for powering a Mars base, as Mars receives plenty of sunlight. However, the efficiency of solar panels can be affected by dust storms and other weather events, which are common on Mars. Therefore, a Mars base would need a backup power source, such as a nuclear generator, to ensure a constant supply of energy.
Living on Mars would require significant adjustments to daily life. Astronauts would be confined to a small space for extended periods, with limited access to resources and social interactions. The monotony of their daily routines could lead to feelings of boredom, loneliness, and even depression.
To combat these challenges, astronauts would need to maintain a daily routine that includes regular exercise and mental stimulation. They would also need to learn to live and work closely with their fellow crew members, relying on each other for support and camaraderie.
One of the biggest challenges of living on Mars would be obtaining food and water. Astronauts would need to grow their own food using hydroponic systems or other sustainable agriculture methods. They would also need to extract water from Martian soil or ice, which could be a challenging and resource-intensive process.
In terms of physical health, astronauts on Mars would be exposed to high levels of radiation and low levels of gravity. These conditions could lead to long-term health problems, including weakened bones and muscles, and increased risk of cancer.
To mitigate these risks, astronauts would need to exercise regularly and wear specialized suits to protect themselves from radiation exposure. They would also need to monitor their health carefully and receive regular medical checkups.
One of the main scientific fields that a Mars base would allow us to study in depth is geology. The red planet has a unique geological history that could offer a wealth of information about the formation of our solar system. Scientists could study the planet's crust, mantle, and core, and investigate the potential for mineral and resource extraction.
Another fascinating area of research on Mars is astrobiology. The planet's past and present environments offer an opportunity to study the origins of life in the universe. Researchers could look for signs of past or present microbial life, investigate the potential for future habitability, and search for evidence of any potential extraterrestrial life.
Climate science is another area where a Mars base could make significant contributions. By studying the planet's atmosphere and weather patterns, scientists could gain insight into how climate systems work on other planets. This information could be applied to our understanding of climate change on Earth, as well as the potential for terraforming Mars in the future.
Other scientific fields that could benefit from a Mars base include physics, astronomy, and robotics. For example, Mars could be used as a base for observing distant objects in the universe, free from the interference of Earth's atmosphere. Robotics could also play a significant role in Mars exploration, with the potential for developing and testing new technology and techniques for space exploration.
In addition to the scientific benefits of a Mars base, there are also potential economic and technological benefits. A successful Mars base could lead to the development of new industries, such as space tourism or resource extraction. The technological advancements required for Mars exploration could also have applications in other areas, such as medicine or energy production.
One of the biggest challenges of building a Mars base is radiation exposure. Mars doesn't have a magnetic field like Earth, which protects us from harmful solar and cosmic radiation. Astronauts would be exposed to high levels of radiation, which can cause long-term health effects, such as cancer and genetic mutations.
Another challenge is the frequent dust storms on Mars. These storms can last for weeks or even months, covering solar panels and blocking communication signals. The fine dust can also be harmful if it enters the lungs or equipment.
Creating a self-sustaining system on Mars is also a significant challenge. The base would need to produce its own food, water, and oxygen, which would require advanced technology and a sustainable source of energy. Transporting all the necessary equipment and resources from Earth would be costly and impractical.
Additionally, the isolation and confinement of living on Mars for extended periods can have mental and physical health impacts on astronauts. They would need to maintain a strict exercise regimen to prevent muscle and bone loss and find ways to cope with the psychological stress of living in a small space with a limited number of people.
The potential for Mars colonization is a topic that has been widely discussed among scientists and space enthusiasts. If we can overcome the challenges of building a self-sustaining base on Mars, it could pave the way for the permanent settlement of humans on another planet.
However, there are many challenges to be addressed before we can even consider colonization. The harsh Martian environment poses a significant threat to human life, with factors such as radiation exposure, extreme temperatures, and low atmospheric pressure all requiring careful consideration.
Furthermore, sustaining human life on Mars would require a constant supply of food, water, and other resources. One possibility is to use local resources, such as water ice, to create a self-sustaining system. But this would require significant advances in technology and infrastructure.
Despite these challenges, the benefits of Mars exploration and colonization could be significant. It could open up new opportunities for scientific research and technological advancement, and could even help to ensure the survival of humanity in the event of a global catastrophe. Overall, the future of Mars exploration and colonization is a topic of great interest and potential. With continued advances in technology and a strong commitment to space exploration, we may one day see humans living and thriving on the Red Planet.